Okay, let's start with starting three-phase wound rotor induction motor experiment. We'll go fast. You know that the purpose of this experiment is to make the motor run fast and slow. Okay, this is the primary circuit and this is the control circuit. Here, this is the wound rotor induction motor because we have an access to the rotor, so we can insert resistive loads. So if we insert resistive loads in connection, Y connection, then because of the resistive, the rotation of the rotor will be slow. So if we make those connected, the rotation will be slow. If we make the short circuit connected, the rotation will be fast. So that's the purpose. We want to control that that connection by a control circuit. Let's see here. We have start. We press start, so the current will flow through the switch, not through the holder, and then this contactor will be energized. When this is energized, actually it was open. It was normally open. Now it will be closed. Okay, and this holder will be also, it was open, now it will be closed. So the current now will flow here through the contactor. So now you can leave your finger from the push button. Now, when this is energized, this red lamp will be on because it's parallel to the contactor, and it needs 120 volt to be on. Let's say we press the fast. I'm going to use the green. Let's say we press the fast, this push button, you press the fast. Now you close the path, you close the switch, and the current will flow through the switch. This contactor, our contactor, will be energized. This contactor will be energized. When it's energized, this was normally open, it will be closed. This was normally open, it will be closed, and this was normally open, it will be closed. When this is closed, now we create a short circuit. The current will go through the short circuit, not through the resistive load, and now it will be fast. The rotation will be fast. But the red lamp is, it will, yeah, by the way, we have no holder right here, because since we close this, we make a big holder right here. That's a holder. That's a holder. This is a holder, so no need for another holder. The red lamp now, when this is energized, when this is connected, the red lamp will be off. Why the red lamp will be off? Because we create a short circuit. This is the short circuit right here. This is my short circuit. In this case now, you will see that the red lamp is off because we create a short circuit. And the green lamp will be on. The green lamp will be on because this is energized. So this is energized, this will get 120 volts. So now we make the rotation of the rotor fast, or the motor fast. You want to go back and make it slow? You press the slow, means now you will break the circuit, and now everything will go back to normal, which is connecting the rotor with 100 ohm, 100 ohm, 100 ohm, which is a slow. You just break the current, and this will be de-energized, and everything will come back to the normal process, which is slow mode. That's the starting of three-phase wound rotor induction motor. So the objective there is just to make the wound rotor induction motor running fast or slow. We're done with that. Let's come here. Let's see here. This is DC braking of three-phase induction motor. DC braking of three-phase induction motor. This is the primary circuit, and this is the control circuit. And now we have a DC part connecting to the stator. Since we are looking to stop the motor, sometimes if you have inertia, if you have a load, heavy load in the motor connected to the shaft, if you just stop the motor, it will take time. It will take maybe 2 minutes, 3 minutes, 1 minute. I don't want to wait all that time. So I want to brake it immediately. Let's see what will happen here. We will start. So when I start, this one was normally open. So I press the start. I make the current flow through the switch, and then the contactor and contactor will be energized. When this is energized, I have those. This is normally open, this is normally open, and this is normally open, right? And this is normally closed, normally closed. So what will happen now when this is energized? When this is energized, this will be closed, 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 and this is open, open, because we don't want the DC to be on while the AC is on. The AC will create a magnetic field, AC magnetic field, and the DC will create another magnetic field. We will have an issue, okay? So let's see now. Now the motor is running, okay? And the holder is here, already left. Now you can leave your finger up because this is energized. This will close this, so the current will flow here. Okay, let's see now. I want to brake. I want to brake the motor. I want to stop the motor. Press. And we have the black. So now I will. This is the switch. I mean, this is the push button. I will press the push button. So the current now will flow through the push button, and the DC breaker contactor will be energized now. When this is energized, this was normally closed. Now, sorry, normally open. Now it will be closed. Now it will be closed. What else? It will be closed. This will be closed now, and this will be closed. But still, there is no magnetic field from the DC created there because those still open, right? Is that what's going on now? Is that what's going on? Because here, we're still waiting for the TDO. No, the DB here, guys. We forgot the DB right here. No, actually, when the DC breaker energized, this will be closed, and this will be open, right? When this is open, this will be de-energized. And when this is de-energized, this will be going back to its normal case, which is normally open. And those two contactors will go back to their normally case, normally closed. Okay? Now, this is connected. Now the DC is connected. The DC is connected to the stator, so we create another magnetic field. We have a previous magnetic field, which is the AC magnetic field. We create another magnetic field opposite to the magnetic field that we have. So when we create an opposite magnetic field, we create a mechanical force. That mechanical force will make the motor stop either immediately or after a time, maybe after 2 seconds, 5 seconds. It depends on the amount of the resistance. So the more current that I have here, the more magnetic field that I create, the faster that I will stop. The less amount of current that I will have here, the less magnetic field that I will create, the more time it will take me to stop the rotation. The TR, actually when this is energized, the time relay will be energized. The time relay will be energized. And this will be TDO, which is after time. So I will study my rotation. Okay, because how long it will take? Approximately maybe 5 seconds. Okay, I will make my TDO, time delay, to open after 7 minutes. Okay, my rotor will stop, or my motor will stop in 5 seconds. I will set the time here after 7 minutes, after 7 seconds to stop. Because, okay, when this one stops, when this one open, means no more current going to the DB, the DC breaker. So it will be de-energized. When it's de-energized, this will open, this will open. Now, I don't want to feed the source. I don't want to keep feeding the stator with with magnetic field or with current from the DC source, because this is wasting, and also I'm producing heat and all that. So I want to stop immediately after the motor stops. So after the motor stops, I want to stop my source feeding the stator. So this is the experiment, and the idea of this experiment is to stop the motor either immediately or with a time, with a certain time. We decide by the amount of resistance right here, and also we decide when to disconnect the source, the DC source, by the TDO. Okay, thanks a lot, and those are the two experiments. Thank you.